Alrighty, this is the Chapter 3 review. I'm going to go through some of the problems that are on the half sheet that you may or may not have picked up in class. I'm going to change the directions in the first one. If you don't have this sheet, then don't worry about what I'm about to say. But the directions on the sheet were to determine if equations were the same lines. What I'm going to do instead is just convert them from standard form into slope-intercept, or from slope-intercept form into standard form. So for the first one, I'm given an equation that is in slope-intercept form. Again, slope-intercept form is y equals mx plus b. Standard form is the one where your variables are on the same side of the equation, ax plus by equals c. And remember, I wanted a and b to not be fractions. So that's what we are going to do in this case, is get this equation from slope-intercept form into standard form. So the first thing we want to do is get this whole chunk to the other side. Again, we want our variables on the same side, so I'm going to add 3/4 x to both sides. So now the left side of my equation says 3/4 x plus one of those y's equals, and I have -2 on the right hand side. Now again, I have my variables on the left side, but I don't want that fraction there in the denominator. So what I'm going to do is multiply everything by 4. So what happens here is these cancel. When you multiply 4 by 3/4, your numerator and your denominator both have a 4. So you are left with whatever is on your numerator, which is the 3 and the x. When you have your 4 here times y, you have 4y. And then you have 4 times -2, which is -8. So I am in standard form now. We have ax plus by equals c. The next one that I want to do is take a problem from standard form and move it into slope-intercept form. So I'm going to take -24 plus 6x equals -8y. And I want to write this as y equals mx plus b. So the first thing I'm going to do is kind of flip-flop both sides of the equal sign. I'm going to get this whole quantity to the other side. So I'm just going to rewrite this as -8y equals -24 plus 6x. And again, what I want this to be in is this form, y equals mx plus b. So we're going to need to flip-flop using the commutative property. I'm going to change around the right-hand side by writing it as 6x minus 24. So far I haven't done like really any algebra besides just moving stuff around using properties. But now what I want to do is get y by itself. So in order to get this y by itself, I need to divide everything by -8. So I end up with y equals 6 over -8x, and I have a negative divided by negative, so it's positive, and 24 divided by 8 is 3. The last thing that I want to do here is just simplify my fraction. So I can divide both of these things by 2. 6 divided by 2 is 3. -8 divided by 2 is -4. So my final equation then is, in slope-intercept form, is y equals 3 over -4x plus 3. The next problems that I want to do are also not on that half sheet. We will get to those. I'm actually going to find some intercepts on the next one. So what I'm going to do is put two equations up here. I'm going to do y equals, let's do -2/3 x plus 12. And then I'll do another equation, and I will do 3x minus 2y equals, we'll do -12 though. And what I'm going to do for both of these is find intercepts, the x and the y intercepts. So I'll make a little note up here, find intercepts. So in order to find the y-intercept, you had to substitute 0 in for x. So that's what I'm going to do first. I'm going to substitute 0 in for x, and that will give me the y. So that goes away. So your y-intercept is 12. So when it comes to a coordinate, just make sure you understand, I substituted 0 for x, and we got 12 for y. So your coordinate's going to look like this. For your x-intercept then, we need to substitute 0 in for y. So 0 equals -2/3 x plus 12. And this one looks a little bit trickier to solve. The first thing I'm going to do is actually bring the 12 over to the other side by subtracting it. So now I have -12 equals -2 over 3x. And I'm going to do this in a couple parts actually. What I'm going to do is get the 3 to the other side, and the only way to do that is by multiplying. Right now 3 is on my denominator, so if I want to bring it to the other side, you need to multiply both sides by 3. So I end up with -36 equals negative 2x, and then all you have to do is divide both sides here by negative 2. And if I do that, I'm going to end up with x is going to equal, and negative over negative is positive, and it's 18. So as a coordinate though, now I have my x part of the coordinate is 18, and the y part of the coordinate was where we had stuck the 0. So here are your two intercepts, 0, 12, and then 18, 0. I'm going to do the same colors for the next one. Now this one's starting in standard form, but I'm going to do it the same exact way. So if I want to find the y-intercept, you substitute 0 in for x. So I get negative 2y equals negative 12. Divide both sides by negative 2. So my y-intercept is negative 12 divided by negative 2, which is positive 6. So as a coordinate, again, it's going to match what this blue one is too. We had substituted 0 in for x, and our y value was the 6, so that's why I put the 6 into the y part of the coordinate. And I'll switch to the reddish-orange color. And this one, again, when we find the x-intercept, now you're going to substitute 0 in for y. So this little chunk will go away. 3x equals negative 12, and if you divide both sides by 3, x is going to equal negative 4. Negative 12 divided by positive 3 is negative 4, and that is the x part of the coordinate, so negative 4, comma 0. So again, that was just a little, a couple examples, a little brief on there, but those are a couple examples of how to solve for intercepts in both of slope-intercept form and standard form. Now I'm going to move to what is on that half sheet. It says for problem number 2, Firestone Tire Service sells the snow tires for $80 each and the mudder tires for $110 each. It's a family that owns 15 vehicles. For whatever reason needs to replace tires. That part is not important. The family has a budget of $2,000 for replacing their tires. So it first wants me to model or write an equation, and then it wants me to define the variables. We're going to define the variables first, where I'm going to say S is going to equal snow tires, or the number of snow tires, and I'm going to use M for the number of mudder tires. Sounds like off-road type. Okay, so now that I've defined my variables, I can write an equation for this. So the question is, how much is a snow tire? So in the problem, it says they are $80 each for the snow tires. So 80S, $80 per tire, plus it's $110 for the mudder tires. And it says that the family has a budget of $2,000. So we're going to be looking at the different combinations that we can for the number of snow tires, the number of mudder tires that the family can buy. So I've defined my variables, I've written an equation, and now I'm going to solve for the intercepts, which is what we had just done. So if I want to first find the intercept for the number of snow tires, I would substitute 0 in for M, which in context of our problem means you would sell 0 of the mudder tires and only snow tires. So this will solve just like our problems before. That goes away, and I have 80S equals 2,000. So I'm going to pull out the calculator. Where's my calculator? Okay, and then 2,000 divided by 80 means my answer comes out to 25. And where's my cursor? There we are. Oops. So S equals 25, and that would be snow tires. So if I'm going to make a coordinate out of this and have S be the number of snow tires and M be the number of mudder tires, in this case my intercept would be 25, 0. Your other end of it would be to substitute 0 in for your S. So if I did 80 times 0, meaning 0 snow tires and only mudders, your equation would look like this. So the first part of it would go away, because multiplying by 0 is 0, and I would be left with 110M equals 2,000. So if I just take 2,000 and I divide by 110, I end up with 18.18 tires. So for us then, you can't buy the 0.18, and we can't afford to round up, so I'm going to write 18 tires as my intercept. So what that one would look like is to put in 0 for snow tires and 18 mudders. Okay, and those again were your two intercepts of it. And then the last part of this says the family purchased 5 Snow Fighter tires, what is the most mudders that they could purchase? So I'm going to take our equation. I'm actually just going to copy this. I'm going to go on to the next slide, and I'm going to paste my equation. Okay, so this is our equation we used. And I'm going to pose this question again in case you don't have the sheet in front of you. It said the family purchased 5 Snow Fighter tires. What is the most mudders that they could purchase? So hopefully you're thinking to substitute the 5 tires in here. That's how many they bought. So 80 times 5 plus 110m equals 2,000. So 80 times 5, 8 times 5 is 40. So $400 is how much they spent on just the snow tires. So if we're going to solve this equation, we would subtract the 400 first, which in context of my problem, that 400 is, the answer that we end up with here is how much money they have left to spend. So that comes out to 1,600, which means there's $1,600 left. So if I take $1,600 and I divide it by that it costs $110 per mudder tire, I end up with 14.55 tires, which again, you can't buy the 0.55 of a tire. I can't round up because that would cost way too much. That would be over $2,000 then, which is out of my budget. So we have to round down. So your answer is 14 mudder tires. That's how much the family can afford. And then